Hello friends. I welcome you all on this our first premium webinar on sustainability and packaging. Just to give you this packaging connection and to tell you briefly about packaging connections, we are a packaging consulting company, the team of packaging professionals working with.
Sorry, I made a mistake because I was on the mute, so I just restarted. Hello friends, welcome you all to our first seminar on the educational series on sustainability in packaging. This seminar is by the team of Packaging Connections, which is a India-based packaging consulting company. It's your destination for anything in packaging and working with many German companies and many other projects with the different multinationals, India, abroad, and also the author of the big book packaging. But we come to the one. Before actually we move to the subject, I would like to show a small video. So you will see that how the life is without packaging. So can you imagine a life without packaging like this? And that too, if there will not be any plastics, what will happen? So this means, though there's so much noise around the disadvantages of plastics in packaging, but at the same time, there are so many advantages also for the convenience and for the human life to grow and live in a better conditions. And that is the reason there is a need for a balance between the good and bad qualities of plastics and packaging. And now we move to our presentation, sustainability in packaging. And Gronia Jain from Packaging Connections, she will take you through. She is the one who was heading the research on this sustainability in packaging and has brought it to you. Over to Gronia.
So again, welcome to Packaging Connections webinar on sustainability in packaging. 2020 has been a very interesting year so far for all of us and has only added to our knowledge of sustainable measures during adversity and how we can continuously work towards a better, safeguarded future for all of us. We're excited to share with you our insights on sustainability in packaging today, hoping to provide you with some resourceful takeaways from this presentation. To begin with, I must answer, why another webinar on sustainability? A question that must across each one of your minds. Sustainability has emerged with great vigor in the past decade and has quickly gained a lot of popularity as a concept. However, we constantly battle between asserting what is known and what is being done. Sustainability is more prevalent today than ever before. A few reasons being plastic and single-use packaging's return due to COVID, an unreduced exponential increase in environmental degradation, and adverse effects of pollution. But what is sustainability? There are many different viewpoints regarding this broad discipline, and the definition continuously evolves to meet the needs of the time. In simple terms, sustainability is maintaining an adequate supply of resources, keeping in mind the economy, the environment, and the society. Sustainable development is development that meets the needs of today without compromising the ability of the future generations to meet their own. In packaging, the pillar of environment has been ignored for a long time in favor of the economy and due to social comfort. Among the broad categories of types of packaging, plastic as a packaging material is the most harmful to be used. And ironically so, it's almost as if we replace the planet with plastic in our considerations. Historically, plastics have been used in various industries due to its low cost of production, ease of use, popularity, and most importantly, its versatility. In packaging specifically, we have also appreciated its hydrophobic nature and its moldability. Unfortunately, plastic is also non-biodegradable and releases harmful toxins such as dioxins and other pollutants during its production, use, and breakdown. It is also made from non-renewable fossil fuel stock. As the statistics show, the packaging industry has made large contributions to environmental degradation. It is both the largest producer of plastic and largest generator of plastic waste. 40% of the plastic produced in packaging is single-use. Over the years, we have seen the situation get worse and worse to the stage that it has now started impacting our daily lives. These stats are an indication that the packaging industry's carbon footprint is unacceptably high, and the continuation of our practices will ultimately fatally choke our oceans. The environmental impact of landfills, toxins and leachates polluting the groundwater, and the dangers of methane buildup will continue to be a threat without drastic revolution. We clearly cannot continue to use our traditional packaging practices. As you can see in this graphic, crude oil extraction and plastic production are very polluting, and they lead to the creation of microfibers, microbeads, and also lead to packaging in landfills. These affect human health and also cause ocean pollution, which leads to marine biodiversity degradation. Eventually, it also ends up in the human food chain. we can see that plastic is deteriorating the quality of life at every stage of its existence. So how do we replace a billion-dollar industry with equally cost-effective and more environmentally friendly alternatives before it's too late? As members of the demand and supply chain, we need to think about areas of reform. These areas will include stages of production, use, and disposal. A considerable reform in production would be to switch from petroleum-based material to plant-based packaging. Now, by definition, plant-based simply means made from a plant source. It does not necessarily mean a bioplastic and is not necessarily biodegradable or compostable. It may or may not be edible. For example, Fekai's mushroom packaging is made using mushrooms but is not a bioplastic. It is, however, 100% biodegradable and compostable. Bioplastics is another broad term for material which could either mean bio-based plastics or biodegradable plastics. Before I go on, let me clarify these terms for you. Bio-based means made from a plant material, and that's it, the complete definition. Biodegradable means able to decay naturally with the help of microorganisms and in a way that's not harmful. Compostable is anything that can be used as compost when it decays. Composting usually requires human management and is faster in terms of breakdown, while biodegradation can be left to take care of itself. The catch here is that almost any product and material is bound to naturally degrade eventually. For example, PET takes around 450 years or more to decompose, and in that case too, it is only broken down into microplastics. But that's not what we're aiming for when we search for biodegradability. What we want is material that naturally and safely breaks down into natural elements of the earth, including carbon dioxide and water. Now, coming back to bioplastics. They're referred to as plastics because even though they're bio-based, they show characteristics similar to petroleum-based plastics. Bioplastics are not necessarily biodegradable, compostable, or even recyclable. Bioplastics, when used to refer to biodegradable plastics, simply means either bio-based or petroleum-based plastics that can degrade into nature into simpler, non-hazardous forms. You can read more about this subject on our website in the blog section. So ideally, we would want all plastics in use to be both bio-based and biodegradable or compostable. Here we see an example of a bioplastic. Polylactic acid, or PLA, which is derived from biomass, is biodegradable, mechanically recyclable, and has characteristics similar to polypropylene, polyethylene, and polystyrene. PLA is a fragile thermoplastic. Thermoplastic meaning materials that can be melted and reshaped without significantly degrading their mechanical properties. They're derived from renewable resources such as cornstarch, tapioca roots, sugarcane, or the like. PLA is made from the processing of the lactic acid present in these plant sources. It's non-toxic in its solid form and safe to use in the food industry and for medical application. It can thus be considered carbon neutral in its life cycle.
PLA, however, also has its own concerns. It's not a wonder plastic at its own because PLA plastic is a biodegradable. It will only be decomposed within 3 months when it has a very specific and controlled composition conditions. So it's not that way we have a PLA and we throw it and it's like the job is done. So when we talk about the commercial compost facilities are available, then only it can happen. In a landfill where a large part of it is still ends up, it can take somewhere between 100 to 1000 years to decompose. So we got to be careful, where do we landfill it? And the PLA is chemically different from plastics. Its mixing in disposal can contaminate the recycling process. So we have to be very, very careful. Suppose that you want to use biodegradable plastic to store your food. In the long run, it sounds advantageous to use a plastic that, under the right conditions, will not be laying around for centuries. In the immediate future, you want your food to stay fresh for as long as it's possible. So this is a problem, especially for food exports. And sometimes people think that PLA will be degrading fast, so food may not be safe, food may degrade, but which is not the case, because food degrades much faster than the PLA, and the food shelf life, whatever we want in the PLA plastics, will be good enough to complete its own lifespan. PLA by itself is brittle and is not as strong or crystalline as petroleum-based plastics. But that's not really a problem. You can design your system in such a way that it can reach to its destination and not likely to degrade as fast as food. Unless you transport it in the controlled conditions which are equivalent to degrading the PLA. So we have to be careful the transporting conditions, and it should only land up into industrial composting solutions.
So BioFutura and Avani are examples of companies that make PLA containers. Another bioplastic, polyhydroxyalkanoates or PHA, and its most commonly found kind, polyhydroxybutyrate, are biodegradable polyesters produced by the bacterial fermentation of sugar and lipids. It can be used to replace traditional plastics in single-use packaging and to make foils and films. It is very similar to PP and PE in its characteristics. PHA and PHB are, however, very costly to make as compared to petroleum-based plastics. The lower hydrothermal stability of PHB causes difficulties during processing with conventional polymer processing equipment. PHB undergoes quick and substantial molecular weight drop and changes color from yellow, white to brown, and also loses final rheological and mechanical properties. PHA as a group is too quick to biodegrade. Full Cycle has been working on its PHA technology to develop a completely environment-friendly production and disposal cycle. They use organic waste as raw material and non-GMO bacteria to create naturally occurring, compostable, and marine degradable PHA. After use, organic PHA can be upcycled back into virgin PHA. This is, however, still a work in progress. So here, to give you a better idea, is a comparison between a bioplastic and other plant-based packaging. So we just discussed the characteristics of PLA, which is polylactic acid. On the other hand is SCOBY, which is an abbreviation for symbiotic culture of bacteria and yeast, which is neither plastic nor bioplastic. It's pure cellulose, like paper, and it can be heat sealed like plastic and is also edible.
And now that there's another challenge which is coming up. More and more we are moving towards bioplastics, biodegradable. So we need enough land to grow it. Now the choice is whether one should grow the corn to create PLA or bioplastics, or should they grow real food items. And so competition is changing, but that is something we have to address, because we cannot just be growing more plastics and not the food.
This graph by the European Bioplastic Organization will provide you with a better sense of what can and cannot be categorized as bioplastics. As mentioned before, ideally, we would want all the plastics in use to be from the quadrant with the overlap of biodegradable and bio-based, so PLA, PHA, PBS, and starch blends. Reforms in use have been continuous, even though it might not have always been for sustainable purposes. The 3 Rs have been around for more than 6 decades now. However, the definition and application has evolved. In 2020, reduce means to eliminate any waste that is not necessary. An example would be edible packaging, usually made from seaweed, cornstarch, and the likes, that has been implemented for food products with short shelf lives. To get into what edible packaging might signify, all edible packaging is biodegradable, but not all biodegradable packaging is edible. We've been using edible packaging for ages, with or without knowing it, like the ice cream cone. But now the focus is on replacing less environment-friendly packaging with edible packaging wherever possible. Not PLA is a pioneer in this industry. Uhu, one of its products, is a thin film material made from gel-like seaweed and other plant-based material, which is completely edible and biodegradable. It was implemented to create flexible packaging for beverages and sauces. Uhu biodegrades in 4 to 6 weeks and is directly consumable. It's also cheap to make. Not PLA's recent innovation is a biodegradable and home-compostable box that could replace plastic containers. It is made using their liner technology, which employs a unique formulation of seaweed and other plant-based extracts, making it grease-proof and water-resistant. EvoWare is also known for its seaweed packaging, and in recent times, casein packaging has also been studied. Not all edible packaging is plant-based. Designed by Swedish company Tomorrow Machine, this too shall pass is a line of packaging which is used with its contents. The packages are said to have the same lifespan as what it holds. One of its packaging designs, used to hold liquids like creams, smoothies, and juices, is a gelatinous pack made of agar-agar and water. Another is a biodegradable, triangular-shaped pack that is used to hold dry food products like rice. It's made from beeswax, which is not plant-based, and is peeled like a fruit to be opened. The last one is made from wax-coated caramelized sugar and cracks like an egg to release the contents. Another example of reducing unnecessary waste is Flipkart's new initiative to reduce plastic packaging by 50% in its own supply chain. They've made an effort to replace plastic with paper in all packaging, hence reducing their carbon footprint. The principles of reuse have been used to elucidate the concept of a circular economy. As defined by the Ellen MacArthur Foundation, a circular economy is based on the principles of designing out waste and pollution, keeping products and materials in use, and regenerating natural systems. TerraCycle's Loop system has formalized how its customers reuse their products. By developing longer-lasting packaging for the products of partner companies, they provision for their customers to return the packaging, which is then cleaned and reused in the cycle. It is, however, questioned if this system increases or decreases the carbon footprint per use. Recycling today does not only mean to recycle used products, but to also make all new products with recycled material, hence completing the cycle. Greenbox makes all its pizza boxes using recycled cardboard. In addition to be made from recycled material, the top of the box breaks down into 4 sturdy plates. The bottom transforms into a storage unit for leftovers, completely eliminating the need for any wasteful material like plastic wrap, aluminum foil, and disposable plates.
And now we talk about reforms in disposable. See, when we are producing so many things and we are consuming so many things, then obviously we have to dispose them. But incineration, landfilling are not good. So that's the reason there are a lot of novel technologies have been researched for the disposable sector, which are either better alternatives to polluting practices like incineration and landfilling, unlike recycling and reusing. Recycling and reusing, they do nothing but delay the whole process. But ultimately, the problem remains same. Only thing it is postponed. So to overcome that, there is also a now better environmental methods where anything can be disposed, and which is called plasma gasification. Gronia will explain you more what exactly plasma gasification is.
So plasma gasification is a process that takes all waste, including hazardous waste, as input and produces non-toxic slag, which can be used as construction material for roads, and syngas, a mixture of hydrogen and carbon monoxide, which can be used in the generation of electricity. There is no incineration, no methane, and no landfills involved in this entire process. It's also a low oxygen process, which produces very few polluting oxides. You can read more about plasma gasification on our website in the blog section. What is surprising is, despite being a high efficiency and a much cleaner alternative to conventional disposal practices, minimal investment has been made to further explore and implement this technology. There are currently only 5 facilities in the whole world implementing the process of plasma gasification. Another issue due to the lack of implementation in the sector of its disposal is that of recyclable and compostable materials ending up in landfills. Most bio-based plastics cannot be home composted and can only be industrially composted as they require microorganisms at high temperatures for degradation. Currently, there's a lack of composting grounds to implement widespread production and use of compostable bioplastics. As of today, most bioplastics still end up in landfills. So essentially, the only benefit of bio-based plastics is the alternative renewable source of production. According to a study conducted by BioCycle, of the 95 facilities that responded in the United States, just over 52 are even allowed to accept compostable plastic products based on their permit. In another study, of 103 recycling facilities that responded, less than 50 accept compostable plastic products as feedstock. Another statistical analysis by BioCycle again shows the global waste composition by percent and the global treatment and disposal of waste also by percent. Ideally, if 44% food and green waste is generated, then all of it should be composted, which is clearly not the case. Only 5.5% of the total waste is composted. It can also be seen that a large amount of waste still ends up in open dumps. Having considered these instances, what we at Packaging Connections observed was that there's a need to break away, or rather transform the demand and supply cycle. Since the masses are comfortable using traditional products, because of both economic and social cultural factors, they're unable to develop a deep enough emotion for sustainability that they must. Manufacturing companies too take into account this resistance and are unwilling to take the risk of adding costs without immediate returns. This trend follows through all the members of the cycle. Packaging producers meet the requirements of the manufacturers and retailers, and this leads to a lack of mainstream sustainable alternatives. The disposal system too suffers the same fate.
And to give you much more realistic picture, we at Packaging Connections installed a global survey to find out hands-on what exactly is happening in this area, so that our exercise is just not theoretical, but it is also the practical, which we can implement. And the survey was participation we had from the packaging suppliers, we had the packaging user company, packaging managers, and everybody else around. And we also asked about the circular economy, and we asked about the plasma gasification, and the many more different things. What is bioplastics? And we found out that there is a lot of confusion in the market, and which now Gronia will take you through with our survey findings. Yeah.
So as you can see, the results show that there's a lot of unawareness and uncertainty about the benefits and implementation of novel technology. In that case, it's only certain that companies would be unwilling to invest in such alternatives. In these few responses that we've put together on this slide regarding opinions about circular economy and its effect on plastic waste generation, we observe that industry members appreciate the idea of a circular economy in all aspects of production, use, and disposal, and would also be willing to implement a more stringent set of standards for the same. There are multiple constructive ideas for evaluation, especially that of the carbon footprint of plastic replacements. The takeaways from the responses to this question have been put together on this slide.
And we will send you the copy of the presentation.
When asked for further development, early onset of consumer education is suggested. Natural products, biodepolymerization, pyrolysis, and incorporating single-use plastic into the circular economy have also been mentioned. The takeaways from the responses have been put together on this slide. The survey takers were also asked what technologies have been implemented at their companies and how. The takeaways from the responses to this question have been put together on this slide.
Now the big question here is, are these steps really adequate? Because we talk about, okay, lightweight, reduce thickness, do some sorting, but this is more of a kind of, I will not say exactly band-aid, but this kind of band-aid is not giving us a long-term solution. So we have to take a step, we have to really take a quantum jump.
So considering these responses from industry members, we're still a long way from actual implementation of adequate measures at individual stages and lower levels of the economy. To be able to see any actual improvement, we need to actively enforce measures at every step of the way. Coming back to our cycle, each stakeholder must work independently and parallelly and do their own part without waiting for others to do theirs first. So what comes next in this ongoing battle to achieve absolute sustainability? Constant, active, accurate, and reliable consumer education, which draws a direct connection between the problem and the people, is what can cause a mass movement. While the general population has become a lot more aware in the past couple of years, we're still a long way from overriding the emotion of convenience with caution. There needs to be a demand for well-established corporations serving global markets to break away from their trends. Sustainability cannot be limited to an indie brand emotion and should definitely not be reduced to a marketing strategy.
Now, when we talk about this, so you can see that clearly there's a problem with the awareness, and there's a lot of problem with the coordination of the different people, and especially with the user companies. They know they have to take the steps to correct it, but how to correct it, what to do, because they are only having half knowledge about it. And I think the packaging suppliers also need to do a lot of education to them, that what exactly the awareness is the key thing. Once there will be a real good awareness, then only the interest will be created. And once there is a serious interest, then obviously it will move to the decision. And when the decisions are taken, the actions will happen. So the awareness is the key thing here, because our survey, personal interaction, everywhere we find, everybody realizes that this is a problem, and a lot of steps which are being taken are taken from the point of view of the government requirements, regulatory. So just to prove, yes, we have done it right, but they are not taken in the holistic manner, in a complete thing, so that it really has an impact. And everybody is taking more of a isolated individual steps, but that is not the answer. We need a bigger level of aggregation, consolidation into it, and and then the things can happen.
So life cycle assessment, or LCAs, have been widely suggested and talked about in today's industry. Life cycle assessment during the design process can significantly impact our understanding of environmental bearing of any product we introduce to the market. A life cycle assessment is defined as a systematic analysis of the environmental impact of products during their entire life cycle. During an LCA, environmental impacts are evaluated through production, use, and disposal phases. This also includes the upstream and downstream processes associated with production, for example, the production of raw, auxiliary, and operating materials, and with disposal, which includes waste treatment. There are many online and offline pre-programmed softwares now available to make the lifecycle assessment of a product easy. The Gavi Packaging Calculator by Spira is an LCA calculator specially designed for packaging. The web-based configuration tool allows you to create lifecycle assessments and to simulate alternative packaging design. At the heart of the tool is a fully parameterized LCA model that traces the entire packaging product lifecycle. It contains dozens of Gavi datasets on materials and manufacturing processes that play a role in the production of packaging. Ecodex is another lifecycle calculator by Celeron, which caters to industries not limited to packaging. Ecodex allows product developers to easily make a sustainability assessment of a product based on the evaluation of carbon footprint, water use, energy use, land use, and other criteria. It allows one to make early decisions and to compare alternate ingredients, packaging, manufacturing, and sourcing scenarios. A very important step in this journey is the standardization of terms associated with sustainability. Any claim about the level of eco-friendliness should have a reference point that takes into account quantifiable measures like carbon footprint. Certifications from ISO and/or ASTM should become a necessity. Mass production and use of sustainable products will automatically reduce their price and make them more consumer-friendly. As you can see, sustainable products are significantly higher in cost than less eco-friendly alternatives. People have also historically rejected eco-friendly products due to the reluctance to accept any trade-offs for the benefit of the environment. A close-knit community of professionals around the world that truly care about the sustainability mission and are willing to share their ideas with one another can accelerate the change we wish to see. Considering the intangible benefits such as better life, longer life, and lower investment in healthcare should incentivize us to make changes in both our personal and professional lives. It is clear from all that has been mentioned so far that sustainability is not a one-action solution, but a continuous process. No matter what the current measures, there will always be a need to find something better. For now, some opportunities we need to consider are investing in in-depth packaging audit before market testing. This will also include a complete life cycle assessment that aims to make products carbon neutral, if not carbon negative. Replacing conventional packaging material with newer, better materials is a risk we must take. Implementing plasma gasification and pyrolysis at lower levels of disposal, for example for hospitals and lamination companies, can lead to accelerated change. These changes, of course, will be accompanied by many challenges, such as an upfront and uncertain monetary investment, and might also not be received by the market with open arms. We have collated a list of few noteworthy innovations from the past few years that can give you a better idea about tangible measures to take. Mondi Asnia CAC technology has made 100% cellulose non-woven wipes a possibility. They're fully biodegradable and even show an improvement in quality in terms of absorption and lotion load. GoGo Squeeze packages its juice in recyclable, squeezable packaging made from a single type of BPA-free polyethylene. No aluminum would be used, and plastic in the helicopter cap will be reduced by 40%. The outer packaging is made from 100% responsibly sourced recycled paper. Top Pans paper-based tube uses 30% less plastic than the commonplace laminated toothpaste tube. There's a reduction of 50% in plastic volume from the body and a total reduction of 65%, including the redesign of the head section. The thinner film material makes it easier to squeeze, but the tube pouch still maintains its shape even when the volume of content inside decreases. Nestle Aquarel has launched its 100% recycled plastic water bottle in Spain. AIM Plus in Spain is working on the MD Plus 2 project. It aims to develop sustainable processes for producing, recycling, and composting plastics. Enzymes were used instead of metal catalysts to obtain polyesters. This reduces the toxicity of these metal catalysts and lowers energy consumption during the polymerization process. In addition, treating polyurethane-type polymers with selected isolated microorganisms has been shown to help degrade these polymers by as much as 70%. Polymer-supported enzymes are being included in a molten polymer to improve the biodegradation of different bioplastics under aerobic and anaerobic digestion conditions. BioFresh Pack is made from a blend of starch from cassava processing waste and other compostable polymers. It's a compostable alternative to bio-based polymers for films such as PLA, which is slow to decompose outside of a controlled environment. It also slows moisture loss and has enhanced storage stability of food during transport, even at high temperatures. National Agri-Food Biotechnology Institute, or NABI in Mohali, India, has developed non-toxic edible coating materials to improve shelf life of fruits and vegetables. This packaging is based on polysaccharides from wheat straw and oat bran, which helps prevent spoilage of highly perishable produce before reaching the consumer. The coating is more cost-effective compared to wax coating. Griner introduced a reusable lid for yogurt cups, similar to the ones used for ice cream tubs. Poppets is a water-soluble pot toothpaste brand which eliminates the use of plastic tubes and caps for this essential. Food-grade films are used to encase single-use toothpaste pods. These pods completely dissolve while brushing and are collectively packaged in sustainably sourced biodegradable cardboard and recyclable aluminum. Sulapak uses multiple sustainably sourced raw materials to create microplastic-free and fully biodegradable packaging products. All products can be industrially composted into carbon dioxide, water, and compost. Many companies such as Fraser, Seven Trees, Bioroma have used Sulapak packaging. E6PR's product is the first eco-friendly six-pack ring to replace the single-use plastic rings of six-packs. It is made from compostable materials and byproduct waste. It's both home compostable and industrially compostable and does not harm wildlife upon ingestion. Saltwater Brewery uses E6PR rings instead of plastic ones. Dame's reusable tampon applicator aims to kill the use of single-use plastic applicators. The one-size self-sanitizing apparatus is carbon neutral. It's made of semi-polymers containing mediprene, which is BPA and leak-free, and is built for lifelong use with optimum performance of up to 10 years. Dame also houses rayon-free, organic, and 100% biodegradable tampons. Linhart's post-consumer resin tubes are made of already recycled plastic and also display high recyclability. Corumat makes heat-stable, insulating, high-performance packaging and enables the circular economy. This enablement is done using its material science technology to convert materials into lightweight, strong, tough, insulating end products. The technology enables a profitable system for diverting organic waste from landfills and generating waste infrastructure in the developing world. ArcLight's proprietary process takes complex and unrecyclable plastics to create smart gravel. They work with laminates and packaging, and they're also experimenting with car bumpers and many others. Having plastic sent to ArcLight for processing costs about the same as landfilling tipping fees. Developed by Novomon, Materby is a biodegradable and compostable bioplastic made from starches, cellulose, and vegetable oil. Packaging of this material can be collected as organic waste and can be industrially composted. It can be made into films, rigid and semi-rigid containers, and woven nets. Pens, cutlery, and foam fillers can also be made from Materby. Polyethylene furanoic, or PEF, is a bioplastic made from fructose. PEF is 100% recyclable with an improved barrier against oxygen and carbon dioxide and displays higher strength. PEF degrades much faster than PET. These properties make it suitable material for packaging in the food industry. Developed by Japanese startup TBM, Limex is a material made from limestone and polyolefin resin that can replace paper and plastic in packaging. It's virtually inexhaustible, has high efficiency recyclability, and can be drawn into sheets and pellets. TBM is currently working on biodegradable Limex that replaces polyolefin resin with biomass-based and biodegradable raw materials. Paptic is a bio-based, recyclable, reusable, biodegradable packaging material made of renewable raw materials. All Paptic materials are environmentally friendly and safe to use in everyday operations. Paptic is also a resource-efficient material, and no new infrastructure or machinery is required for its manufacturing. Paper packaging is 100% biodegradable, reusable, and recyclable. However, even though paper reduces the carbon footprint, it requires immense deforestation, which must be compensated for. Using recycled paper and materials sourced from sustainably managed forests for packaging is a highly eco-friendly practice. Corrugated bubble wrap, biodegradable packaging peanuts, and air pillows made from recycled material are a few examples of how paper can replace less environmentally friendly materials in the packaging industry.
So basically, here we come to the end of our presentation, and here are the abbreviations for the different terms which we have used. Just to let you know that it's the end of the day, it's a disclaimer that we have talked about so many different brands and companies, but we don't own anything. They all belong to the respective companies. And here are the references. So when we will send you the presentation, you will get the complete recording and all the references so that you can really use it. And now, in case you have any questions which we could clarify, we will be happy to answer. So I will unmute you now and we will try to answer you. And then you can unmute yourself. You all have been unmuted. I mean, you can unmute yourself and put the question. Hi, Amit. Yes, tell me. You have to unmute, Amit. Okay. You have to unmute, Amit.
Yes, I just unmuted myself. Hi,
Okay.
Sandeep.
Hi.
Thank you. Wonderful presentation. So I think I'm the first one to ask the question. Okay,
Yes.
so my question is that today, the way, so this is a very exhaustive presentation going across different forms of packaging. Now
Yeah.
we are into flexible packaging. This is I manage a company, SB Packagings, and we are based out of Delhi for the benefit of other people participating in this seminar.
Yeah.
Now we are into flexible packaging, and what we've been trying to do is to we've been trying to use monolayer packaging as a way of I think there is background noise, the echo at your end. I think you have two different devices open to the. So you need to probably mute one device at your end.
Okay, I'll mute myself.
Yeah, okay, that's better now. Okay, so what I was saying was that we are trying to popularize the use of monopolymer packaging, but currently the what I see is that in the market today, while we have a lot of options for monolayer packaging with barrier, without barrier for different kinds of foods and other FMCG products, we do not see a lot of traction in the brand owners towards using monopolymer packaging. They are still in there, they want to be in their comfort zone. Until the regulator pushes them, they don't want to move towards this. So that, you had one slide on demand and supply, it's a catch-22 situation. So who bells the cat first? So what is your view on the situation now, and how you think that the situation is going to change very soon? Because the regulation is very clear in India right now. The regulation says that even alternate uses and energy recovery is recyclable. So when we have such a broad definition of recyclability in India, which does not differentiate between a monopolymer recyclability compared to a multi-layered packaging recyclability, which is very, very different. So at this with this kind of a vague definition of recyclability, the brand owners are not really in a mood to change anything. So so it seems. So what is your view on the things in the near to medium term from now?
Yeah, you are absolutely right, Amit. And even during our survey and when we were registering the people for the seminar, even every brand owner, most of the brand owners are talking, they want a solution, but they are not ready to understand how the whole process is. And they think, okay, I want biodegradable, which is a challenge. And I find more and more packaging suppliers are getting involved. They want to come out with a solution. So I think that one slide which I had on the awareness, interest, action, and the decisions, the tree, it is something we have to work, really need to work and really need to do the education. These are the challenges, and we will have to pull out the regulatory authorities. We will also need to teach them, because good thing is they're coming out with the regulations to do something. So they have recognized the issue. But the problem is they don't have the solution. And for the solution, they don't know whom to go. And no one person has a solution. So there's a lot of collation, lot of debate, and we really need to go to the grass level, and somebody will have to really push it hard to work and to do it together. So this can be done only by a strong regulatory interference and the association. Not easy, because sustainability seems to be a big buzzword and everybody wants to make a lot of money out of it, and then that's the problem what is happening, but nobody has a solution. So this is no easy answer, but I think the only thing is that we have to create a lot of awareness.
No,
And
but
this is
right
the
now in the right now the
seminar.
EU, yeah, right now the EU has made a there's a new tax which has been introduced for non-recyclable packaging.
Yeah.
And with the effect from 1st January, it will be applicable with effect from 1st January 2021. Now this is, so they have defined recyclable packaging as so they have ruled where I think 2018 September their new rules came into place, where they said that by 2030 everything should be recyclable, monopolymer and recyclable. So for them recyclability means monopolymer, and they've given a lot of time. They've given 10 years to the industry to convert to monopolymer. So that is the very clear direction, and a lot of time to the industry. And so very, very clear. So European Parliament has been very clear about it in 2018. So they give actually 12 years for the industry to convert to monopolymer recyclable alternatives. Now they have put a tax on non-recyclable from 21. I mean, this is very, very clear steps. Very clear steps to the industry as to what to do. Now something like this is already happening in Europe. Do you think that the impact is going to come to India, because most of the brand owners in India are also multinational companies, and they will have their own sustainability. They will have their own sustainability goals also. So even if the Indian government does not become too strict or whatever, do you think that the Indian brand owners or the multinational brand owners in India will go this sustainability way, the way Europe is going?
No. Answer is no, because the brand owners, they really try to follow the law of the land, and if the government is not pushing, they don't really care, because then every country, they follow the law of the land, even though they may have a global mandate that they will follow sustainability. But if India is allowing something else, they will let it go, because that is the experience I have.
That's very discouraging. Very
Yeah, but
disappointing also.
but that is the truth. because if you remember earlier, there used to be PVC water bottles and PVC bottles, and before the PET was coming, and they were using PET in other countries, but not in India. Only after
Right.
government pushed it, then only they changed from PVC to PET. And again, in the pharmaceutical, when they were changing from PET to glass, again, when the government was pushing it. So we like it or don't, but end of the day, they are also into business. So, and
Okay.
they are not.
So are there
Mhm.
any brand owners in this forum? Would some brand owner like to speak as to what they are doing and what they are doing about it? If there are some brand owners in this forum, we would love to hear from
Yeah,
them also.
the brand owners are there. They have to decide whether they want to speak up or not. Because I think my personal interaction has been that they don't want to speak up in the public forum because eh, the big brand owners are always trying to show something that they have taken some steps, whether they are active really happening or not. So the truth is very hard to come out.
Okay. Well, anyway, thank you very much for this wonderful seminar. I think I will lower my hand now and give opportunity to somebody else who wants to speak.
I think you have touched basically everybody's need, and now we are also done because 5 o'clock, and then maybe we can always discuss often, and anybody else, if they can send us the question, we'll try to address it. And now I would like to take this opportunity to thank you everybody to joining it, and we look forward to see you again, and we will be coming back with a lot of other webinars where we can add value, and we look forward to your feedback. Thank you very much.